An engineering mathematics question, we have to find out the closed form of the generating function for the sequence an for n greater than or equal to 0 given as n plus 1 when n is odd and 1 for the even values of n. So basically for this sequence we need to find out the generator function. And how do we do that? By writing this expansion such as n plus 1 x raised to n for the odd values and 1 x raised to n for the even values. Now we can further expand this term as sigma of n x raised to n plus sigma of x raised to n plus sigma of x raised to n. Now these two are for the odd values while the last one is for the even values of n. So we can expand them into sequences such as the first one would become odd values, so 1 x raised to 1, 3 x cubed, 5x raised to 5 and so on. The second one would be expanded into x raised to 1 plus x cubed plus x raised to 5, so on. And the third one would become even values, so x raised to 0, x squared, x raised to 4 and so on. Now we can have a look at these sequences 2 and 3 that they can be combined together to form a continuous sequence that would be 1 plus x squared, x cubed and so on. And as we know that this particular series is the binomial expansion of the term 1 minus x the whole raised to minus 1. So basically we can combine these two sequences into 1 upon 1 minus x, and that is present in all the four parts as we can see. So we have resolved these second and third sequences and we are only left with this first one. Let us see how we can generate this function. We basically wanted x plus 3x cubed, 5x raised to 5 and so on. Now for the last two series which we used 1 minus x the whole raised to minus 1, this expansion. For this one, what if we use minus 2? That would actually give us 1 plus 2x plus 3x square, 4x cube and so on. This is not the exact sequence which we wanted to generate. So what if we replace x with x squared in this? It would be 1 minus x squared the whole raised to minus 2 expanded as 1 plus 2x squared, 3x raised to 4, 4x raised to 6 and so on. Again, this is not that which we wanted. What if we multiply this with something? Let us say x or something. If we multiply just with x, then these 4 coefficients would be retained. So we need to add something to x. We cannot add 1 x or x squared because again that would not yield the required series. So we'll actually multiply this with x plus x cubed. This multiplication would give us x plus 2x cubed, 3x raised to 5, so on, ignoring the higher power terms. And this would be giving us x cubed plus 2x raised to 5 and so on, again ignoring the higher power 5 and above. On combining the like terms together, here we'll be getting x plus 3x cubed plus 5x raised to 5 and so on. This is the exact sequence which we wanted to generate. And how did we generate that? By multiplying x plus x cubed with the expansion of 1 minus x squared the whole raised to minus 2. So this can be written as x 1 plus x squared upon 1 minus x squared the whole squared, bringing this to the denominator and taking out x common from here. So this is the part 1 of the answer, and part 2 I've already got to be 1 upon 1 minus x. So this would be our answer. And that is present in the option A over here. So this would be the correct answer for this question.